Hey, grade 12s, we're going to work on taking a look at what happens when we provide high voltage electricity into tube sources with different gases in them. We talked about how the electrons, as they go through the tube, will excite the electrons of the gas, and they will jump up to the next energy level when they get hit by the electricity. And as they fall back down, they're going to release that electricity in the form of light. And we're going to diffract that light with a little piece of diffraction gradient. This is just a polarized piece of plastic so that we can get the line spectra for a variety of different gases. So this first light that you see in front of you is argon. And when we hold the diffraction gradient over it, or the polarized plastic, you actually get a nice separation of light. So what I would like you to do right about here is pause this video, and near the top or the bottom, you're going to get a really nice separation of light bars. I want you to do your best to make a copy of that using pencil crayons or whatever you might have. This next tube contains oxygen gas, so we're going to do our best again to see if we can't get a really good separation of the light. Again, you'll notice a series of colored bars. This one's not quite as bright, but you can get the colored lines near the top or the bottom where you can see really nice separation there. It's kind of faint, but you should still be able to do it. Pause the video here and get this spectra pattern for oxygen. This time the tube contains nitrogen gas. Again, with each different gas that we get, we're going to get a different line spectra. Again, near the top or the bottom, we've got a great separation of colors here for nitrogen gas. This time, we have a tube containing xenon. Every different gas that we produce for you will have its own line spectra color. Pause the video here and try and copy down the line spectra pattern for xenon. Notice the large spacings between the different colors of light that is produced. Finally, this bright red light is characteristic of neon. This is neon gas, and it's kind of be a bit tricky for us to try to get a nice diffraction going so that we can separate it, but really at the bottom of the screen I can see the pattern right there. If you pause the video here, you should be able to get these colored bands which show the line spectra for neon. It's also possible to get line spectra for gases that are composed of more than one element. In this tube is carbon dioxide, and you can notice that even carbon dioxide is giving us a unique line spectra pattern. Every different element has its own unique pattern because every different element has a different arrangement of electrons around the nucleus. As the electrons jump from one energy level to the next, and they fall back to their original energy level, called the ground state, they release energy in the form of light, called a photon. And each photon, as it travels, each color of light has a unique wavelength. That wavelength has to fit exactly in between the energy levels of the atom. Because of this, we can actually use spectroscopy to identify different elements from places far away. For example, if I take a look at a star that is thousands of light years away, I can take a look at it through a spectroscope and find out the spectral pattern that it produces, compare that to ones that we know here on the Earth, and from that we can identify what gases are present in the star.